spot. That, yeah, exactly. So the idea is to do everything within the shipping container, you know.
Well, hello everyone. Welcome to the workshop. Obviously, like Sarah mentioned earlier, I'm going to introduce CP3 a little bit. But first of all, I'm going to do a land acknowledgement. We would like to begin by acknowledging that Concordia University is located on unceded indigenous lands. The Kenyan Kehaka Nation is recognized as the custodians of the lands and waters on which we gather today. Geojage or Montreal is historically known as a gathering place for many First Nations, and today it is home to a diverse population of Indigenous and other peoples. We respect the continued connections with the past, present, and future in our ongoing relationships with Indigenous and other peoples within the Montreal community. I'm going to introduce myself. I'm Maeva, and I'm one of the other general coordinators at CP3, or known as the Concordia Precious Plastic Project. And our mission is to reduce plastic waste at Concordia by repurposing it into new recycled items for the community. Furthermore, our goal is in alignment with the Concordia Sustainability Action Plan, and it's also in alignment with the UN Sustainable Development Goals, namely number 12 and 13. And the project also follows the Precious Plastic Methodology, which is an open source plastic recycling project. On the next slide, you can see here that we plan to renovate a used ship container to house all of our machinery and safety equipment. And not only it will be a place to work on projects, but also gain a better understanding on plastic and find better alternatives to repurpose plastic waste. And this is all made possible thanks to our sponsors and their contribution for the workspace and equipment. And finally, in terms of student involvement, you can follow us on social media or check out our website for updates and learn more about our mission and our goals. And as you can see here, we also offer resources and create experiential learning opportunities. So we offer many roles and always looking for new members to join our team as well. So if ever you're interested in joining, you can join through the link here that Sarah will put in the chat. With that, I'll pass it over to fellow General Coordinator Felix, who'll be presenting his workshop on plastic molding.
Great. I will share my screen. Okay. So, yeah, CP3, what is it? It's a community. It's research, creation space, lots of keyword. But it's also an opportunity to learn, and that's why we decided to do this webinar today to teach a little bit about what we do and what we can do at CP3. This is the newest rendering we have of the space we intend to put on the grounds of Greynon. You can see the inside here. And in the front, we'll have some sort of display area where we will sell some sheets of plastics that are made with the sheet press here. And we will also have filament rolls that are produced with this equipment here. And these plastics will all be made of recycled plastic from Concordia waste stream. We'll also have some pellet storage. The pellets are shredded plastic that is produced by the industrial shredder here that we will soon have on Concordia. And with those pellets, we can mold objects into useful shapes. And to do that, we will use the mold press. And the webinar here is mainly about how to create objects with the mold press. So go to the next slide. So what is press molding? So press molding is an early technique for making a plastic object. It's Yeah, it's one of the easiest way to mold objects. So I'll present to you this little video that show how it works. Maybe there will be a loud sound. I will try to mute it soon. It's already muted. So you see that he puts powdered plastic into the molds. It is a bakelite plastic, and then pressure is applied and also heat to set the plastic. There's always a little bit more plastic than needed in the press to make sure that the plastic fill the whole cavity. And you can see here in the part that is on the side that there's some overflow that occur. And this overflow is called flashing. So once the piece is cured, it is ejected, and you have a finished part. How do I stop that? Ha. Okay, so I said bakelite. So bakelite is an early form of plastic. It's a thermoset, so it's not you cannot really recycle it because it's not the type of plastic that you eat and it melts. It's the type of plastic that you eat and it hardens. So it won't be recycled. But it was the kind of object you would make with bakelite, and it was considered a kind of high-tech material at the time. And it was not the type of material you would use for a single-use object. So the mentality has changed. Another material that is that it was used with press molding is the galalite and casein. So it's a plastic made from casein from milk, and it was used to create buttons. This is a part of a guitar bridge, guitar picks. It were thicker than what we are used to today, and also other buttons here. And casein has seen some renewed interest. This is a really interesting project where they use these kind of animal proteins to make a plastic. I don't know what it is exactly. It's an architectural piece that is very interesting. So I'm gonna talk a little bit about trad-in design. Trad-in design is my project that looks at the traditional objects and try to reimagine them for a future use. So for that project, I take a look at traditional arts, and I try to see if these traditional knowledge can be used to enhance the durability of an object to make it last longer in the society. So the main goal is if you, let's say, learn how to do this weaving for your chair, for your computer chair, then when the weaving is all used up from using the product, you can reweave yourself the chair and change the material, and that way you keep your chair longer. But also, if it's culturally relevant to you, you tend to want to repair it more. So it's to make objects that are repairable and that you want to repair. Also, with that project, I wanted to explore culturally sensitive teaching. So I remembered that when I was young, I learned to do rhythms and all that in school with with objects that are fairly distant from my own cultural references. So let's say I learned some rhythms. I used maracas and claves, which did not relate really to me. And my question was, why not use something like this, which is something that we all know, we all have seen, and is really ingrained in the imaginary of everyone in the country. So here are some example of this winter TikToks with La Zigaison Zinzon. So they were all using like spoons to refer to that object that they don't have usually in their house. So it's like something that everyone knows, but no one's really know how to use. So the idea with the musical spoon project is to create an object that could be used um, by children and could be taught to children how to use, and that way kind of create a new standard instrument to learn when you're young in school. And this is what this guy is doing in his music teaching practice. He teach musical spoon to children, and he in this video he is using one of my 3D printed spoon that I designed to make the object more accessible to children. So the spoon that this guy usually uses like $50 for one instrument. It's somewhat prohibitive for children to use this instrument if it's that expensive. But as you can see, a 3D printed instrument does pretty much the job. Yeah, he commented that the sound was really good even though it was plastic and 3D printed. So yeah, if you want to look for this guy online, it's called Olivier Bussière, and he teaches musical spoon. And so that was for me a proof that we could make a musical instrument that is cheaply produced and culturally relevant. So my question was, instead of this annoying toy, why not use this annoying toy to teach music to children? But I had like still some problems in mind regarding this design, because it was 3D printed. So it's not everyone who has a 3D printer. It's more accessible, but it's not everywhere. And also it's made from virgin plastic right now. And I wanted to push that project further and see if there was a possibility to make it out of recycled plastic, and to at the same time teach the children how plastic is recycled and how you can make culturally relevant stuff with it, and teach the children yeah, the whole process. Have them collect the plastic, come in the shop, make the spoon, learn about recycling, and leave with the object at the end. So in the next part I will talk a little bit about my process to create that recycled plastic spoon. So the material I chose to create the mold was ceramics, and this was partly due to the fact that I had a ceramics class this semester, so I had access to the equipment. But I also wanted to encourage artists from the Department of Sculpture, Fine Arts, Ceramics, see that there is potential with their skill to create a wonderful project out of recycled plastic in collaboration with CP3. So I will talk a little bit about the relation of ceramics to other forms of art. Sometimes in ceramics, we tend to see the material in a purist sense. We want to have only ceramics in a ceramic project. But historically, ceramics have been used in the creation of many things that are creative and artful, I guess. And it's really, if you look at like the top chefs, so that was my inspiration. If you look at the top chefs, they really think of the whole thing, the how the dish and the food will come together to create the whole experience. And the artwork is more than just the food or the dish. It's everything together. So I have some example of how varied this experience can be. So you can have something that evokes nature, something that is really geometrical, something that is more I would say natural and gestural. But we can see that mixing material with ceramic is something that is old and I think relevant more and more today. I also found some examples of ceramics being used as mold in the diverse tradition. Here we have a mold of a lamb pastry made out of ceramic, and here this is a butter mold. So I was really thinking about the aesthetic of the mold, and I wanted to create an object that was not just the plastic object, not just the mold, but something that is in a conversation. The mold and the object are both treated equally. So here we have a ceramic mold that is used to create a glass object. So here we have an example of two crafts that influence each other's form. And the next one is basketry. So the art of basketry led to a type of pot that is influenced by the basket. We see the texture of the basket being transferred to the pot. So this was the kind of ideas I had in mind for my own mold. So I took my original design of 3D printed spoon, and I created a mold in the computer to try to make the mold as complicated as I could. I wanted to test the limits of the process to see if I could not only create a simple object, but one that is actually complicated. So the object is two-part. You need to take one half of it and another half and bind them together in the middle here. And to do that, I made some dents here to create a little drill, pilot hole. So a little pilot hole to drill here and to put a fastener in between the two parts. Other feature that are important in this mold is that I have some extra space all around of the object to put extra plastic. And this is what I was telling earlier, that there will be flashing occurring all around. And this is important to make sure that the plastic fill out the entirety of the mold. And if you look carefully, the angle here and here are different. And this is to create some void to help the plastic not get trapped into the mold, but also it creates a choke point where you can go around with a tool and trim the excess material at the end. So that was my basic plan for the mold. And how I proceeded is that I 3D printed the two parts of the mold, and then I made a plaster mold. So in ceramics, you shape the ceramics with plaster to because the plaster will suck the humidity out of the clay. So that's why we use pottery plaster. And that was the result of one of the two molds here. So and the other one here is the 3D printed part is all around and the plaster is inside. And here you see the result. And this process was working good in some way and bad in some other ways. You can see that there is some lines left by the 3D printed part on the plaster. I didn't mind that because I was not expecting a great surface at the end, and so this I didn't worry too much about. But like here you can see that the part got stuck into the plastic and that I had to pry it out with some rougher tools, and it created some holes and problems on the mold that I had to fix later. But all in all, I was satisfied with the process. Here you can see how I molded the parts in my own room because we didn't have too much access to school at the beginning. And so I was able to create 6 parts, so 3 mold in total. And you can see that I had some problems with crevices that was showing because of the way I put the clay in the mold, and these crevices at the seams of when I put the clay together, I tried to fix by putting some engobe into the cracks in many layers in the cracks, and then a full layer all around to coat the inside. So my strategy for that was to put an engobe on the soft, not soft, yeah, I would say the smooth surface inside to make sure that the part would release well. And on the rough outside, I would put a more rough finish to emphasize the duality of the two kinds of finishes. So this is me spraying.
Felix,
Yeah.
we have a question from Emily, and it was, did you mold the outline of the spoon by hand? Like the outline of the spoon in the ceramic by hand?
Yeah, so this one here, like that.
Like, did you outline the spoon by hand? I think you placed the spoon inside, right? Like you had a spoon?
No, it was a so what I did is I had the model of the spoon. I created the cavity in the 3D model, and then I molded the cavity and the male part. So I 3D printed the kind of opposite form of the mold. So that's the part that is a little bit tricky to visualize, but basically it was just saving time to print to print these two halves of the mold. But I could have done it by taking one 3D model of the spoon and creating the plaster molds from that object. I just made it differently to save a little bit of time. But yeah, the plaster mold was made by pouring some plaster over a 3D printed part of plastic.
Perfect. I think that answers the question. Sorry to interrupt you.
Yeah, so that was that was a 3D printed cavity at first, and this is what was put inside the 3D printed cavity. And yeah, so this is spraying glaze over the mold. So by spraying the glaze, I was ensuring that the glaze was not too thick and that the texture would be uniform all inside the mold. And this is sprayed over the green engobe. And the engobe is a type of clay that you put over another clay to make it have a nice color. But in my case, it also served as a way to hide the crevices in the molds. And then I wiped the excess glaze all around and put an oxide. So why I did that is because in the oven, the glaze should not touch the plate of the oven, otherwise it will stick to the oven. And so I decided to go for an oxide rub all around. And also that oxide rub enhanced the rough quality of the outside. And it, in my opinion, created a nice contrast between the inside and the outside of the molds. So here you can have a better look at the inside. And you can see that the cracks are hidden effectively. And here you can see the effect of the oxide rub outside and a collection of the 3 parts. So I did some different treatment. This one I left it white, but the other one I put the green engobe, and here the oxide. And it really helps to show the details. So here you can see the fingerprints and all that, and I think it really gave it a utilitarian aesthetic, which is derived from the use I will do of the object. So it didn't need to be very smooth on the outside. So I didn't made it smooth on the outside. I used I used the function of the object as a constraint for the aesthetic. So I had my mold. I was happy with the results. So I did the first test on how to make the object at the end. So I have here my shredded plastic. I did that with scissors in my house. So I took some bottles of plastic. It's HDPE, so number 2 plastic. And then I put my mold in the oven. I poured some of the shredded plastic in and heat it up until it's clear. And that was my cue. So because I was doing that outside, it was kind of hard to know the real temperature inside the oven. I put it at 300 at first, but I had to crank it up to 400 to get to a clear stage. But I don't know, I didn't stick a thermometer inside the plastic to know the exact temperature, but HDPE is very it's very clear when it's ready. It becomes translucent and you know it. So I went by eye instead. So then I closed the mold, put a brick on it, let it cool in the oven, and that was the result. A little bit disappointed by the initial result. It got stuck in the mold somehow. So my initial thought was that HDPE has a reputation for not sticking to anything. Was not true. It got stuck in the mold, and I had a very difficult time opening the mold even, and at some point I even shattered part of the mold. But you'll see that I found solutions for that. But this was my first result. For the next stage, I used some bigger parts, some bigger plastic shreds, and instead I put a sheet of how is that called, parchment paper. It's a silicone coated paper that you can put in the oven. So I put that on a baking sheet, and also I coated the inside of the mold with the traditional Murphy oil soap. So everyone who's doing ceramics mold will know that Murphy's oil soap is the way to go to make sure that your model doesn't stick to the plaster, and it's friendly to use. It's non-toxic. It's very safe. So I tried with that, and it ended up working great. So I recommend that. It leaves a little bit of oil though on the part, so we'll try to find a better solution maybe in the future. But it's a good good way to proceed. So you can see that I had some modification made to my mold. I used plaster and fiberglass to reinforce the part that shattered. And because I didn't know what was gonna happen, I wanted to reuse the one that shattered to make sure that I don't break another one. But I also added a handle on in the design of the mold, and that made it very easier to manipulate and use. So I maybe in the future, if I do something like that again, I'll think about my usability more in the design, and how the mold will be handled while we use it. So the shreds are put on the sheet, heat it up, and I can show you, I think this is a video, yeah. So I can show you how I proceed, because then I had a good feeling about the results of that one, and I got the camera and started to film. So this is the short montage. So here I use a silicone spoon to press the log into shape, and I kind of preform the spoon. I make like some kind of blank before I press the spoon, so it's already in the right kind of shape. Then when I finally press the spoon with the second half of the mold, it will be it will give a better result. And sometimes you see me touching the plastic with the gloves. So I really recommend getting a good pair of leather gloves, not using oven mitts, because you kind of need dexterity to do that. And it's really important to be protected, because it's really sticky and it sticks to the glove. And I don't even recommend touching it with the gloves, because it kind of stuck to the gloves. So in the design of the mold press, the machine, we will have a car jack to really press the mold together. On that example, I'm pressing with my hands, but it was not ideal. But it kind of worked for what I was doing. Then I'm trimming the excess material here. And again, I recommend using gloves, and I switched later with a glove because it was kind of scary to do. And you can see that my choke point wasn't really the best. So there was some gap in between the molds. Maybe it was not pressed enough or something. And the flashing was quite thick, so a little bit hard to trim, but I was able to do it in the end. And I think in the left, yeah. So it was kind of quick at the end, but you can hear the results of that. Oh no. Hold on. Okay, so I'm almost done with the presentation of this step. Hold on. And so this is what it looks like. This is like the log that I made with melted plastic, and I made that by folding over the sheet of coated parchment paper. And yeah, as I said, using a spoon to pre-press the shape was really useful. So I really recommend using silicone tools to go with to work with the plastic. And so you can see here how it's really pre-shaped before I do the final pressing. And this is the shape of the object inside the mold. So you can see here what I described as the choke point. It should have been more choked, I guess, here, and that would have made the trimming process way easier. And also, I was missing some plastic at the back here, and yeah, but what's great is with the choke point is that it creates a very defined line where you can trim the object. And I have some pictures of the results, and this is how I intend to present the object in future exhibition. So I really want to show the object in relation to its mold and how it was created. And this is it. The floor is open for questions, and thanks for listening to my presentation.